Welcome to class. Sorry, we are on video and not Zoom. Here we go. If you log into your modules here, you've noticed I've put up a video link to your homework if you want to watch me go through the steps. And then there are your answers for 721. We are on week 23. Okay, so A-Day is going to do 723 on law of cosines, and B-Day is going to do 722 and 723. On Thursday, I will be live with A4, and we will apply everything we know about triangles to word problems. So today's video is going to be on 722 law of sines, and this is for B-Day on Monday. Here is an overview of what we're going to learn this week. Students will develop law of sines and use it to calculate missing side lengths and angles of non-right triangles. Okay, that's the big part there, non-right triangles. Students will recognize the relationship between the side angle and opposite that in the triangle. And then students will develop the law of cosines. So since this is for B-Day, we are doing 722 law of sines. Our teamwork is going to be 63 to 67 on Desmos. And then you do have a homework assignment. I took out number 72. And then on Wednesday, you're going to watch another video like this on 723. Just 2 teamwork problems. It probably won't be that long of a video as today. And then your homework problems 80 through 86. And that's it. So let's get going here. In your modules, on that next slide there, shrink. Okay. So we have no Zoom for today. You guys get 5 points for watching the video and 10 points for doing your Desmos activity. Okay, so you can go into 722 teamwork. Click on that and go ahead and go into B2 or B4, whichever class you are. B2 or B4. Should come up looking like this. Just so I have more space today, I'm going to be flipping to a screen that has a little more space with the problems on it. Okay, so I don't have to shrink and write and all my stuff gets saved. So it says here in chapter 7.2, we're going to learn the law of sines. Last class, we did a problem at the end. Okay, it was kind of complicated. We had to calculate the side lengths of the missing angle of a right triangle. So this wasn't a right triangle. Okay, we don't have that nice square in the side of one of those angles. So there is a tool we're going to learn today that's a lot fewer steps than what we did last time. You guys remember last time we did this? I thought I turned it on. Okay, we drew a line down the middle of that. Found a right angle. Okay, and then calculated all the sines using our sine, cosine, and tangent. So we're still going to use this triangle. Okay, and this is just our notes page. Okay, so you guys want to refer back to this page to get all your notes. Here's the big ones that we're going to do today. Is that we know the sine of A is proportional. So if we go sine of A and the sine and the leg across from it is proportional to the sine of angle B and the side across from it. And that's also proportional to angle C and the side across from it. Okay, once you have all those letters filled in, your ABC and your capital ABC, you can solve this area of a triangle. And you guys will notice whatever you pick for sides A, B, and C, it doesn't matter. Okay? If you or your friend all have different sides, it won't make a difference because they're all proportional in the end. Okay? And then I just am going to keep putting these up there. The sum of all angles adds up to 180. And we can use our Pythagorean theorem as a tool. Okay, and our sine, cosine, tangent of theta equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. So let's move on to 763. And this is where I'm just going to switch pages slightly here. So I have the same problems, except that's a 764. Where's my 763? What? So in 763 here, I don't know why I don't have a 763. $764. So funny. So funny. Okay, I'll do 763 on the other page. So 763, is there a relationship between the triangle's side and the angle opposite to it? Okay, so we're looking at if we have angle A, here's my angle, and I'm saying, is there a relationship to the side across from it? The side across from it's labeled BC. Okay, is there a relationship from angle C to side AB? And is there a relationship between angle B and the side opposite of it, AC? So let's order our angle measures from largest to smallest here. Angle A has 105. All right, angle A, 105. Angle C has 63. And angle B, we're going to go 180. Minus 105 minus 63. Remember, all three sides add up to 180. So our third side there should be angle 12. Okay, so that's my biggest angle to my smallest angle. And if we know anything about angles, okay, the biggest angle is going to open up wider, okay? Angle A opens up wider, right? It's 105. it's going to open up wider than angle 12. Okay, angle 12 is going to look small by angle B. So this only has an angle of 12. So it would make sense that 105 has the longest side, right? My 63 has the middle length. So angle A, 105 degrees. Don't know where my degree button is. And it would be the longest side. Angle C, 63 degrees. It has the middle side. And angle B has 12 degrees. So it's the shortest side. Okay, let's move on to 64. And this is where I'm going to switch my screen here. Sorry about that. Okay. Does Madeline examine the triangle at the right? She says, I don't think that the diagram is drawn to scale because I think it's labeled, the side labeled X has to be longer than 4. Well, let's see if she's right. Okay, let's fill in that missing angle first. Okay, that should be the easy part. We need to move that up into our screen. Okay. Draw. So we have 180. Oh, I don't want it that big. There we go. Minus 42 minus 26. Which is 42. Should be 112. Okay. So if we're going by that theory, our angle opposite of 1012 should be the longest. Our X should be the middle. And our 26 should be the shortest. Okay, so Madeline thinks that the S side, the 4 centimeters should be the shortest. So that thing doesn't look to scale, does it? The X side should be longer. Okay, so yes, I agree with Madeline. We're going to go 112 longest, 42 X middle, and 26 for shortest. B says Layla, or I don't know, Leela, thinks that X can be determined by using right triangles. Review what we did in the last lesson by calculating the value of X. Okay, so I remember last time we took our angle here, our triangle, and I'm going to see if I can zoom in on my triangle. You know what? I'm going to just make it bigger. we have 42, 4, x 26. And we made this at 112. Okay, so last time we don't have a right triangle, so we have to draw a line down the middle. And we're making 2 right triangles. And we're going to go back to that first page and we're going to pick one of these functions. So we're going to pick sine of our angle equals opposite over hypotenuse. Cosine of our angle equals adjacent over hypotenuse. Tangent over our angle equals opposite over adjacent. So I'm going to start with one of these angles that I know. Okay, this whole thing is 112. We're not going to use that. Let's start with this 26 here. And I know this line down the middle is not your hypotenuse, but it is your height. So we're going to call that h. So if I look here, I have an angle, I have an opposite, and I have a hypotenuse. Okay, so that first for B here, we have the sine of 26 equals h over x. That doesn't help me yet. I still have 2 variables there. Okay, let's try the other triangle. Let's go from 42. So the sine of 42 equals h over 4. Well, that's more helpful. Okay, I can multiply both sides by 4. And I'm able to type this in my calculator. So we're going to get our Desmos calculator out here. We have the 4 times the sine of 42. So we have 2.68. 2.68. So I can plug that in for h up there. Oh, I don't need to erase. Okay, so I have the sine of 26 equals 2.68 divided by h. Here's where it gets a little tricky, right? We have to multiply both sides by h. And then if I want to get rid of this sine 26, I have to divide by sine 26. So basically I'm kind of cross multiplying. Just trying to save space. Divide by sine 26. Okay, I can type all this into my calculator. So I have 2.68. And I'm going to make it more precise. And I'm going to hit answer. Okay, divided by sine of 26. So I get 6.11. 6.11. I'm going to fill in my graph. H is 6.11. Oh wait, I lied. H is not 6.11. H is erase. Because I didn't mean to say we needed to multiply this by x. So this was x times the sine of everything. My x equals, my h is 2.68. And my x is 6.11. So now we have almost everything filled in. The only piece we're missing is this bottom part of our triangle. Okay, so far we've done a sine function and a sine function and found our missing angle. So those 3 functions we've had to do already. And this is find the area for letter C. So area of a triangle is 1/2 base times height. Okay, we know our height is 2.68, but we don't know what our base is yet. So we have to do 2 more functions to get that base. So we already have the h in the middle, so we can just use that again. So the sine of 26, oh, sine's not going to get me there, right? That's opposite and hypotenuse. If I go from that same angle and I use cosine of 26, that'll get me there. Okay, let's call this B1 and B2. So the cosine of 26 will give me B1 over 6.11. And the cosine of 42 will give me B2 over 4. So I can multiply this side by 6.11. And I can type 6.11 cosine of 26 equals B1. 4 times the cosine of 42 equals B2. Um, 6.11 times the cosine of 26. 5.49. Four times the cosine of 42. We get pretty close to 3. Okay, if I were to round that to 5.5, if we combine both of those together, this whole side equals 8.5. So we can finally use our area formula. So the area equals 1/2. Our base is 8.5. And our height is 2.68. So 1/2 times 8.5 times 2.68. Whoa. 8.5. We get 11.4. 11.4. Moving on. Okay, let's go to 675. 675. So this is where we're going to start figuring out the relationship of how they're equal to each other. So it says Tao and Ivan want to come up with 2 different ways to calculate the height. Okay, and you guys should have just moved on to the next slide. I'll make sure I click that over when I have to click to this side. Okay. So we got Ivan and Tao. It says using the right triangle on the left, Tao writes sine 58 equals h over 12. So I'm going from sine of 58 equals my opposite over hypotenuse. And Ivan writes the sine of 24 equals h over 25. So they just did the same thing we just did. Okay. And which triangle did Ivan use? Okay. Ivan used the triangle on the right. So let's plug both of these into our calculator and see what we get. So we're going to type in sine 58 equals h over 12. Multiply both sides by 12. I get 12 sine of 58 is what I'm going to type into my calculator. $12 sine of 58. Should get 10.17. 10.17. Let's try it Ivan's way. Remember, you guys, they're both calculating for h, right? So our goal here is to get them to be the same answer. So you have sine of 24 equals h over 25. Multiply both sides by 25. So you're going to type in sine 25 times sine of 24. So we have 25 times the sine of 24. Ah, pretty close. 10.17. Okay, so my h is 10.17. So these two are exactly the same. They're the letter h. Okay, so we can relate both of these triangles using sine functions to get the same height. So let's try this on 1150. Did I shorten this in your book? I did. I think your problem here is a little shorter. So it says, Edwin wonders if Tao and Ivan's methods can be used to relate this in terms of letters here. Okay, so use the triangle on top here to write 2 expressions like we just did with Ivan and Tao. That one on mine. I'm going to go next page. Yeah, okay, so same thing. So use the triangle to write. So we're going to use letters this time instead of numbers. So try from angle A. Write a sine function. So sine of theta equals opposite over hypotenuse. And use the letters in here. First start with the one on the left, angle A, and then write one for angle B. So we got the sine of A equals h over b. All right. The other one says the sine of b equals h over a. part B here is basically saying we want to prove sine of B over B equals sine of A over A. We're trying to try to rewrite these equations so we get that. If I did the same thing I did last time, I'm going to multiply both sides by B. So I get B times the sine A equals H. If I multiply both sides by A, I get A sine B equals H. Since both of these equal H, I can set them equal to each other. Nope, B. We're almost there. These both have the little b's under the fraction, or the little letters under the fractions, instead of having them multiplied. So if I divide this side by B, get rid of that one. If I divide this side by A, okay, I get rid of this one. So we have sine A over side A equals sine B over side B. And then take a look at that, you guys. We have our little b is across from the angle. Our angle A is across from the side A. If we did the same thing, our angle C would be across from little side C. So this relationship's called the law of sines. Okay, in your math note box for 722, you can read more about this. I put a link up in your notes here. If you click on that, it'll bring you right to your textbook 722. So let's go ahead and try to solve this triangle. And it's the same triangle on, I don't think I did that one. It's the same triangle on the next page too. Okay. So we're going to use these answers and plug them in on the next page. We're just looking for x. Okay, so if we're using our sine B over B and our sine A over A, what's that going to look like? So I'm going to go across here, right? I have this sine of 120 divided by the side across from it equals the sine of 28 divided by the side across from it. Okay, so how do I clean this up? We can cross multiply. 10 times the sine of 120 equals x times the sine of 28. Get x by itself, divide by the sine of 28. And it's always best to type this in all at once. Okay, so 10 times the sine of 120 divided by the sine of 28. 10 times the sine of 120 divided by sine of 28. Double check all my numbers were correct there. Yeah. Okay, we should get 18.4. 18.4. So my x equals 18.4. So on your next page, you guys, you're going to use that information on your next page. Okay, so we know that x equals 18.4. We can use the law of sines to find area. So this is our area formula. The question is, do we have all this information yet? Okay. We have, let's just say this is, it doesn't matter, you guys. This is A, this is little a. This is B, this is little b. This is C, this is little c. So we're going to match all those up to make sure that we can have all these variables filled in. So we have little a equals 10. We don't know little b yet. We have to solve for that. And we know our big C is 120. So we can make another proportion up to solve for little b. Or we can be even sneakier. Right? B, C. No, we can't. We still got to find them all. All right. So we have this sine of 120. You know what? I still feel like I don't have to do that. Like I said, you guys, my A, B, and C, where I put them, shouldn't matter, okay? So as long as I have A, B, and C on there, so we have an angle. Let's try to go, we can go C again. And then angle I don't need that C. I don't know why I want to do C there. Let's go angle C. So this is side C. Angle A. And angle B. Remember, they're all proportional, so it doesn't matter where we put them. I just want to put them in spots where we don't have to solve more triangles. Okay? So now we have an angle, we have a little a side length A is 18.4. The side length B, little b is 10. And our big angle C is 180 minus 120 minus 28. So our area formula, we have the area equals 1/2 times 18.4 times 10 times the sine of 32. Type all that in. You get 48.7. Our area equals 48.7. I know that's been a long time. Okay, so on your own here, I want you to solve for x. A you can do using the law of sines. B, you can use your probably sine function. And C, you're also going to have to use law of sines. Okay, give those a try. Have a nice day. Thank you very much.